All right, hey guys, today we're going to start introducing the concept of unit rates, which are also known as constant of proportionality. There's going to be a couple slides just to review ratios because it has been a while since we've talked about ratios. And then we're going to get into just the basics, the really basic basics of unit rate and constant of proportionality. So just as a review, a ratio is a comparison of two numbers or measures using division. A ratio can be written three ways, 3 to 5, 3/5, or 3 to 5. And the 3 to 5, this mark here in the middle is called a colon. And then you can also write it out with a word. Ratios are often expressed as fractions in the simplest form. They can also be expressed as a decimal. Any fraction can be expressed as a decimal. So if we start with the fraction 5/20ths and we simplify it, we can divide both the numerator and the denominator by 5 evenly. So 5 divided by 5 becomes 1. 20 divided by 5 becomes 4. So whatever you do to the top, you do to the bottom. So 5/20ths equals 1/4. And then every single fraction is a division problem. When you guys are doing ratios and proportions on the MAP test, you should be able to use a calculator for every single question. So, really super simple way to go from a fraction to a decimal is to just type in the numerator 1. This would be like the divide sign, divided by 4. 1/4 is equal to 0.25. And if you want to talk, a ratio is a comparison of two numbers with the same units by division. A ratio may be written three ways. That's just a review. Okay, so we're just talking about basic ratios here. We have a pattern with green tiles and purple tiles. What ratios can we form from the tiles above? So we have part to part, part to whole, and whole to part. Remember, the order that we write these matters. So it matters. So if I would say, so one part of this would be the green tiles, and one part would be the purple tiles. So if I say green to purple, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12 green tiles to 1, 2, 3, 4, 5, 6, 7, 8 purple tiles. So I have 12 to 8. If I say part, let's go green to whole. So there are 12 green tiles, which we already counted before. And then the whole would be total tiles. 12 plus 8, green plus purple, is 20. Of course, I can simplify that down. Let's see here. 4 goes into both of those evenly. 12 divided by 4 is 3. 20 divided by 4 is 5. And then if I want to do whole to part, this time let's do the whole to the purple parts. So we know our whole is 20, and our part that is purple is 8. Okay, so I can come up with 3 ratios really easy right here. I can even come up with more if I'm super creative and smart. All right, so this is just a really simple review that when you are talking about ratios, just like fractions, you want to put them in the simplest form possible. So the ratio of 5 to 300 in its simplest form. Nope, the ratio of 50 to 300 in its simplest form. Excuse me. Let's see here. I can divide 50 divided by 2. That would get 25. To 300 divided by 2 would be 150. I can go even farther than that. Let's see, I can divide both of those by 5 because this one ends in a 5 and this one ends in a 0. So 25 divided by 5 is 5. 150 divided by 5 is 30. I can go even farther. I can divide them by 5 again. 5 divided by 5 is 1. 30 divided by 5 is 6. So the simplest form of this fraction, of this ratio, is 1/6. 53 hundredths is the same thing as 1/6. All of these fractions that I've come up with are equivalent fractions, or if we're talking ratios, equivalent ratios. All right, so is there another way you can write these ratios? Again, this is just looking at equivalency. The ratio illustrated on the top has 4 filled cells to 10 total cells. So the ratio of filled to total is 4 to 10. And then on the bottom, the ratio of filled to total is 2 to 5. But if you look at this, something should be jumping out at you. You should say, even though the ratios look different, this one is 4 to 10, and this one is 2 to 5, even though these ratios, these numbers look different, the actual pictures look like the same amount is filled. This means that they are equivalent. Ooh, that's an E. So these ratios are equivalent to each other. There we go. Now we're going to get into unit rate and constant of proportionality. To find the constant of proportionality, which is the same thing as the unit rate, and I double-checked with Mr. Edwards today, the map test will talk about this one concept as both the unit rate and the constant of proportionality. So just get used to seeing these and knowing that they mean the exact same thing. So when you find the constant of proportionality or the unit rate, you would find the cost or the amount for 1. The rate when the denominator is 1. So how much for 1? So if Ms. Zeider runs 5 miles in 1 hour, her unit rate would be 5 to 1. If Ms. Zeider runs 10 miles in 2 hours, you have to do some math and figure out how much it would be for 1. Again, it would be equivalent ratios. Simplifying, I would run 5 miles in 1 hour. So the constant of proportionality. So if it costs $78 for 13 sandwiches, what is the constant of proportionality? To start finding this out, and again, we can also call this the unit rate, you set up a ratio. So if I'm going to set up, a ratio of dollars to sandwiches. Dollars to sandwiches. In this particular ratio, it is $78 for 13 sandwiches. And you want to make sure that you keep them, keep the ratios the same. So if my dollar is the numerator up here, then the dollars need to be the numerator up here. Sandwiches, sandwiches. Like I said, you can use this on you can use a calculator on your map test. I'm going to use a calculator here. So if I clear this. Okay, so 78 divided by 13, 6. So remember, every fraction is just a division problem. So I just typed in 78 divided by 13, and I got 6. So for 1 sandwich, it costs $6. And again, this is just creating an equivalent ratio. So the unit rate is $6. Whoops. For 1 sandwich. All right. So the cost of a 12-ounce box of Cheerios is $3.29. Schnucks brand Cheerios cost $4.89 for an 18-ounce box. Find the unit rate to find the better buy. So we want to know which one gives us a better value. Per ounce, which one is cheaper? Now, most adults don't have a solid understanding of unit rate. So a lot of adults will go into Schnucks and see, oh, this $3.29 box of Cheerios costs less than the Schnucks brand, $4.89. I'm going to buy the cheaper one. But which one are you actually getting more Cheerios for less money? So let's find out. So we're going to set up a ratio for the name brand Cheerios. So it's $3.29 for 12 ounces. Let's figure out what that is for 1 ounce. It's just a simple division problem. Again, you can use your calculator. So we can do 329 divided by 12. Gives us 274. I'm going to round. 0.274166667. So I'm going to round that to 0.274. Now for the generic brand Cheerios, they are $4.89 for 18 ounces. When I divide that out, we get 0.270. So, which one is cheaper? Same. 4 is more than 0. So the generic brand Cheerios are actually cheaper than the name brand Cheerios per ounce. You're going to see miles per gallon a lot. Just know that this means like how many miles a car can go if they only burn 1 gallon of fuel. So if you're buying a car, you want to have a car that has higher miles per gallon, meaning that you can travel farther on just 1 gallon of gasoline. So gasoline is expensive, and you want a car that goes farther for each gallon of gasoline that it burns. Okay, so we're going to get into comparing, finding constant proportionality as it applies to miles per gallon. So I want you to make note of the way that I say miles per gallon. You will always hear it written like that. So if I do miles per gallon, this P means per. Anytime you see that, I want you to think of that as like the fraction bar or the colons in a ratio. So if it's miles per gallon, that means miles goes on this side and gallons goes on this side. If it's miles per gallon, okay, the miles is the numerator and the gallons is the denominator. So we have how many miles? 250 miles. And how many gallons? 11 gallons. To find a unit rate or the constant of proportionality, it's a really simple division problem. I'll pull out my handy dandy calculator. It will be 22.73 after I round it. So 22.73 is our miles per gallon. So this car gets 22.73 miles per gallon, which is fine. Okay, so now we're going to work on comparing two ratios and using the constant of proportionality to solve more complex word problems. So first you're going to write them as proportions. You're going to set them up as equivalent ratios, but there's going to be one number missing. So this is another way to solve that last problem. We have 250 miles and 11 gallons. So we are traveling 250 miles on 11 gallons. We want to know how many miles we can travel on 1 gallon. We're going to solve using cross multiplication. Now, for this problem that I've just shown you, we did it much easier than it would be here. It's not always going to be like this. So, to do cross multiplication, I'm going to multiply 11 times x. Since I don't know x yet, it's going to give me 11x. And then I'm going to multiply 250 times 1. And I'm going to solve this equation. Mr. Cook has been teaching you how to solve these equations like this. So I got to get this x by itself. I got to isolate that x. To do that, I'm going to, instead of multiplying by 11, I'm going to divide by 11. I can't just divide by 11 on one side. I have to divide by 11 on the other side. 11 divided by 11 equals 1. 1 times x equals x. So when I divide by 11, that gives me x by itself. 250 divided by 11, we just said, was 22.73. So this is just another way for us to see that on 1 gallon of gas, we would travel 22.73 miles. You're going to use this cross multiplication a lot coming up in the next couple weeks. So even though this problem seems very simple, I want you to understand how we solved it. All right, thanks guys. Bye. That was way longer than 10 minutes, wasn't it?